there. Because if they if a function that was a quadratic function that was linear, and you want to solve and find the point where I expect that. So, we need to be quite close. If we're not reasonably close, we could have a situation with more complex functions where there are very quick turns and we could go completely the wrong side of and look completely in the wrong place for a root. So, firstly, we could make a graph of the function manually or using some kind of graph plotting software like the image on the left. That kind of indicates that there are roots somewhere around about between 1 and 2, in -1 and -2 is a root somewhere there. Okay, so we can make a first guess at -2 or -1, -1.5, whatever we thought was appropriate for either method. And we can see that there's a root between 2 and 4, somewhere just under 3. So we can make an estimate around that area to start the method. Alternatively, what we can do here, and it kind of confirms that a little bit, if we've got this function x squared minus x minus 5, we want to find the roots of that. We can evaluate that at different levels, and we kind of know we can see that we got a root between 2 and 3. But if we evaluate that function when x is 2, we get an answer of -3, and that's this point down here. And if we evaluate it when x is 3, we get a value of 1. That's the point up here. There somewhere. Because they're either side of the x-axis, we got a change of sign between the two results. Therefore, we must the x-axis a root x is equal to 2 and x is equal to 3. So all the time, as you'll see, going through these methods, you're looking for a change of sign to indicate where your root is between two different numbers. And what this is a successive functions method of finding the root from a number. And the idea is you stop around the cycle when you get the same answer to the required number of significant figures twice. Yeah? So you keep rounding your answer to, let's say, the same to it's best served by going through. So what we'll do, x squared, find the positive root correct to 3 significant figures. Okay, so this is what we do. We might a graph to find out somewhere around about there the function x is none or 0, we get minus up here somewhere. So having e right. What we do get here still positive. You figures. Just sum that result up for the video for reference. Pen on. So we knew our next guess was between 1 and 1. So we find there's a new guess every time, that figure there, and we round that to 3 significant figures. And we're looking for this rounding to be the same twice. So then we look at the function, got a positive, tell us between two. Next guess, down to 1.03, put that in the function, 1.03,125. You need to keep at least one, if not two, at least extra significant figures in that guess there. Okay, maybe not all of them, some extra ones, otherwise you're going to go wrong. Okay, we've got to change a sign here. So 1.03125 as our new bottom guess. We're now going to go 03125, and this between guesses now. From there, rounds to 1 significant figures. Put that the relative. So this becomes a new bottom guess because it's negative, and round it to 1.5 for the second figure. Do that when you see sign change. In the bisect time you listen, root between actually look at the middle. Okay? Try and understand what's going on there. Yeah. Oh, how it is. Minus. What? And you x is equal to 1.05 and x is equal to minus 3.25, both the 3 significant figures. which confirms our result using the bisection method. Okay? Yeah. So I've been on to IT because the autographing in this room's not working, and we need a week, so that they're working on that. You can actually use the software to look at a function, look at a curve, and actually get it to use either the bisection or Newton-Raphson method to estimate the roots. And it kind of draws a little graph, and if you zoom in on that, it kind of show you how that's homing in on. So I'll show you that next week, because part of the assignment, and I might go through that. I might do that this morning, actually, Matt, if you're not here this afternoon. Just go through. There's not much of the assignment you can start on yet, but that's something that you can begin to work on from this week onwards. Okay, so I'm going to issue it today. But I will show you how you can do that, because you might want to put something along that lines in the assignment. But it's not working at the moment, so I thought it's useful to do that to show how the method works to number of decimal places. Result. Next page, we're going to have a look at one where I actually solve meat. To x plus e to the x. And we're looking from this point here, where they somewhere between x is equal to 2. One function that's crossing, i.e. first change it so on the left hand side, leaving 0 on the right hand side. For the x both sides to end up with 0 on it. Minus it. As I've already said, is equal to 2. When x is 0, the function is equal to 2. When x is 1, function is equal to 1.28. But when x is equal to 2, we end up with a negative value. We've got to change the sign there. Therefore, the result is between x equal to 1 and x is equal to 2. So that's kind of two methods to find where our first is going to come from. Okay, so on your way to start, these results in a table as you go along. So you can see first guess is between 1 and 2. So being between 1 and 2, that means the guess is 1.5, the result is positive, and the guess to 3 decimal places. So there's no change of sign there, so I go to between 1.5 and 2, 1.75 there, route to 1. So until you get a column of that figure is got a bottom gap. We've got to change the sign there actually. Work that one out. Follow us. Through. Not include gas. To 2 decimal places, the equation 2 ln x plus x equals 2 using the method of bisection. Have a go at that one.